When you think about the machines that changed farming forever, tractors probably come to mind first. But it's the attachments, those often bizarre-looking contraptions that hooked up to these workhorses that really revolutionized agriculture. Today, we're exploring some of the strangest and most ingenious pieces of equipment you've never heard of. And one of these seemingly simple machines sparked a revolution in modern farming that's still influencing how we work the land today. The cornstalk shredder. The cornstalk shredder transformed how farmers dealt with post-harvest cleanup. In the 1940s and 50s, these machines were a common sight across America's Corn Belt, but their story starts even earlier. Before mechanical shredders, farmers often burned their fields to clear stubble, a dangerous and environmentally damaging practice. The shredder's innovation lay in its rotating cylinder, equipped with dozens of hardened steel flails that would spin at high speeds, literally beating the tough corn stalks into submission. But here's what made them truly special. They could handle speeds of up to 7 miles per hour while processing multiple rows at once. The clever engineering came from their adjustable processing height and the way the flails were mounted. They weren't rigidly attached, but instead hung on chains or pivots, allowing them to swing away if they hit something solid like a rock or stump. This self-protecting mechanism meant fewer broken machines and fewer emergency repairs during crucial harvest periods. Some models even incorporated innovative features like adjustable processing intensities. You could set it to barely crack the stalks or pulverize them into mulch, depending on your needs. The shredder's impact went beyond just field clearing. It played a crucial role in pest control by destroying overwintering sites for corn borers and other destructive insects. Potato digger. The potato digger represented a quantum leap in root crop harvesting technology. Before its invention, potato harvesting was backbreaking work that required entire families and hired hands to crawl through fields, digging spuds by hand. The mechanical digger introduced a revolutionary lifting mechanism that combined reciprocating forks with an innovative shaking action. At the heart of the system was its ground-driven cam mechanism that caused the lifting forks to vibrate as they moved through the soil. This vibration was crucial. Too little movement meant potatoes wouldn't separate from the soil. Too much could damage the crop. The most successful designs used a graduated screening system where the initial lift was followed by a series of progressively spaced bars that allowed soil to fall through while moving potatoes toward the rear. Early models from the 1920s could harvest up to 5 acres per day, a massive improvement over hand digging. These machines evolved to include features like vine separators and adjustable pitch controls that could adapt to different soil conditions. Some advanced models even incorporated rubber-coated chains to reduce bruising, a crucial innovation for commercial growers who needed their crop to look perfect for market. The digger's development also led to improvements in potato planting techniques, as farmers realized that uniform planting depth and spacing made mechanical harvesting more efficient. The machine's influence extended beyond potatoes. Its basic principles were later adapted for harvesting other root crops like carrots, onions, and beets. Hay loader. The hay loader might seem primitive by today's standards, but it revolutionized forage handling at a critical time in agricultural history. This attachment epitomized mechanical elegance through simplicity. Its endless canvas belt system, driven by ground-powered wheels, featured wooden slats or steel teeth that would sweep across the ground, gathering hay into a continuous upward flow. The genius lay in its self-regulating speed. The faster the tractor moved, the faster the pickup mechanism operated, maintaining perfect timing. The loader's design evolved to include floating pickup heads that could follow ground contours, preventing the teeth from digging into the soil. Advanced models featured adjustable angle settings for different types of hay and field conditions. The most sophisticated versions included a cross conveyor at the top that could distribute hay evenly across a wagon, eliminating the need for manual spreading. These machines could handle different types of forage materials, from fine alfalfa to coarse prairie hay. They worked especially well in regions with shorter growing seasons, where getting hay into storage quickly could mean the difference between profit and loss. The hay loader's influence can still be seen in modern balers and forage harvesters, which use similar pickup principles, though with much more sophisticated mechanisms. Hey, before we dive into our next incredible attachment, I'd like to ask you to hit that subscribe button if you're fascinated by these forgotten pieces of farming history. Thanks. Beet Topper. The sugar beet topper showcases how specialized agricultural equipment evolved to handle unique crop requirements. This precision implement had to solve a complex problem, removing the leafy top of sugar beets without damaging the valuable root below ground. The engineering challenge was immense. The machine needed to account for varying beet sizes, different soil conditions, and uneven ground while maintaining consistent cutting height. The breakthrough came with the development of a floating head system that used a combination of sensing wheels and hydraulic or mechanical controls to follow field contours. The cutting mechanism itself was a marvel of precision engineering, featuring horizontally mounted rotating steel discs with hardened edges, spinning at over 1,000 RPM. These discs were slightly dished to create an upward air current that lifted the leaves just before cutting, ensuring a clean slice. More sophisticated models incorporated multiple stages of cutting. A first pass to remove the bulk of the foliage, followed by a precision cut to remove the crown. This two-stage approach maximized sugar content in the harvested beets, as the crown contains less sugar than the root. The topper's development also led to innovations in plant breeding, as farmers began selecting for beet varieties with more uniform crown heights to improve mechanical topping efficiency. Wood saw. The tractor-mounted wood saw transformed farm forestry management. Unlike simple buzz saws, these implements were engineering masterpieces that turned tractors into mobile sawmills. The saw's mounting system was particularly clever. It could swing through a 180-degree arc, allowing the operator to position logs perfectly for cutting without moving the tractor. The blade mounting deserves special attention. It used a sophisticated bearing system that could handle both the massive radial loads of cutting and the side loads that occurred when the blade encountered knots or irregular grain patterns. The drive system typically incorporated a heavy-duty belt tensioner that could maintain optimal power transfer while protecting both the tractor and saw mechanism from shock loads. Safety features were remarkably advanced for their time, including blade guards that automatically positioned themselves based on log size and emergency stop mechanisms that could halt the blade in seconds. These saws typically ranged from 24 to 48 inches in diameter and could handle logs of up to 20 inches thick in a single pass. The larger models required specialized blade tensioning systems to prevent wobble at the high operating speeds, typically around 1200 RPM. The saw's impact on farm economics was significant. Farmers could now process their own lumber for buildings, fencing, and repairs, reducing dependency on commercial sawmills. Tree Stump Puller. The tree stump puller represents one of the most powerful mechanical advantages ever achieved in agricultural equipment. These devices were critical for land clearing operations, especially in areas being converted from forests to farmland. The basic principle was simple: mechanical advantage through compound gearing. But the execution was brilliant. The most effective designs used a multi-stage gearing system that could achieve ratios of up to 400 to 1, meaning a relatively small input force could generate massive pulling power. The anchor system was equally clever, using extending arms that would dig deeper into the soil as more force was applied. The pulling mechanism typically employed a hardened steel cable or chain, wound around a drum that was driven through a series of reduction gears. Some models incorporated a unique rocking motion that would alternately lift and pull, helping to break the stump's root system loose gradually rather than trying to extract it all at once. Advanced versions featured telescoping booms that could change the angle of pull, allowing operators to work around obstacles or deal with particularly stubborn root systems. The most powerful units could generate pulling forces exceeding 50 tons, enough to extract stumps up to 4 feet in diameter along with their entire root systems. Crop sprayer. The crop sprayer attachment reflects a crucial transition in agricultural pest control technology. These implements were engineering marvels that helped bridge the gap between early dusting methods and modern spraying systems. The heart of the system was its innovative pressure regulation, a precisely calibrated system that could maintain consistent spray patterns regardless of the tractor's speed or terrain. The nozzle design was particularly ingenious, using specially shaped orifices that produced optimal droplet sizes for different types of applications. The boom suspension system employed a sophisticated parallel linkage that kept the spray height constant, even over rough ground. Advanced models featured multiple nozzle configurations that could be switched on the go, allowing operators to adapt to changing wind conditions or crop requirements. The tanks incorporated baffling systems to prevent liquid surge while turning, and the most sophisticated versions used mechanical agitators to keep chemicals properly mixed. These machines could treat up to 30 acres per hour under ideal conditions, with boom widths on some models reaching 24 feet. Fordson Snow Motor. Next, the Fordson Snow Motor was one of the most extraordinary tractor conversions ever made. Built in the 1920s, it replaced the rear wheels with massive rotating screws, each about 7 feet in diameter and 10 feet long. These spiral drums would literally thread through the snow, while the front end rode on adjustable steel skis. Think of it as a cross between a tractor and a giant mechanical snow worm. The genius of its design was in its ability to work when everything else was stuck in the snow. Those rotating drums could power through deep snow at 3 to 4 miles per hour, making it invaluable for winter logging operations. Each drum turned independently for steering, just like a modern tank. While the conversion kit cost almost as much as the tractor itself, lumber companies in snowy northern states found it worth every penny. Nothing else could keep logging roads open and haul timber through heavy snow quite like the snow motor. Manure Spreader. The manure spreader represents a perfect marriage of simplicity and mechanical innovation. While its basic function might seem straightforward, its engineering was remarkably sophisticated. The heart of the system was the beater mechanism, a carefully designed assembly of paddles and tines that could break up and distribute material evenly. The drive system utilized a ground-driven wheel that automatically adjusted spreading rates based on travel speed, ensuring consistent coverage regardless of conditions. The apron chain system was particularly clever, using a dual-speed transmission that could handle both light and heavy loads efficiently. Advanced models incorporated lime shields to protect the operator from dust and splash, while some featured adjustable spreading patterns for different materials and applications. The most sophisticated versions included mechanical end gates that could regulate material flow and prevent overloading of the beater assembly. Wire Roller. The wire roller represents one of those rare pieces of equipment that not only solved an immediate problem, but fundamentally changed farming landscapes across continents. This deceptively simple machine, which revolutionized fence management, emerged from the great transition from open range to enclosed pasture farming. At its heart was an ingenious dual-speed gearing system that could handle both the initial high-speed collection of loose wire and the increased torque needed as the roll grew larger. The roller's core engineering feature was its self-adjusting tension control, a sophisticated mechanism that automatically maintained optimal wire tension regardless of roll size or wire condition. This prevented both slack rolls that would collapse and overtensioning that could snap aged or rusty wire. The machine's mounting system was particularly clever, using a parallelogram linkage that kept the rolling mechanism at the optimal angle regardless of terrain or working height. Advanced models incorporated wire straightening guides that could handle multiple strands simultaneously, with hardened steel rollers set at precise angles to remove kinks and curves from old wire. The most sophisticated versions featured automatic wire cutting systems that could detect knots or splices and stop the roller before damage occurred. What made this machine truly revolutionary wasn't just its mechanical innovation, it was how it transformed land management practices. Before its invention, removing old fence wire was so labor-intensive that farmers often simply left it in place, creating hazards for livestock and wildlife. The wire roller made fence removal and replacement practical, leading to better pasture rotation systems and more efficient land use. Some models could process up to a mile of wire in under an hour, a task that would have taken days by hand. The machine's impact extended beyond agriculture into conservation. It became a crucial tool in removing abandoned fences from wildlife corridors and public lands. Modern versions incorporate features like hydraulic drive systems and electronic tension monitoring. But the basic principles remain unchanged from those early innovative designs. Perhaps most importantly, the wire roller epitomized the kind of practical innovation that characterized the best farm equipment. It solved multiple problems simultaneously, reduced labor requirements, improved safety, and enabled better land management practices. Its development sparked a wave of similar innovations in fence management technology, including mechanical post pullers and automated fence installation systems.